All right, the first question here is, how do I find the surface? I guess I should highlight find, I don't know. Surface area of a rectangular prism. Okay, find the surface area of the rectangular prism, and we're going to use the net, which means after you unfold this into its two-dimensional rectangles, we use the net to find the area of each face. Let's talk about surface area. Okay. So what we're doing here is we're going to find the area of every one of the rectangles that's on this rectangular prism. Remember, there's 6 of them. There's 6 of them. And so we're going to take all those areas, all of the squares it takes to cover each one of those 6 rectangles, and we're going to add them together, and then we'll have the total surface area. So instead of just area, it's surface area because you're adding together all of the areas for the entire rectangular prism. So we're going to call this SA. Guess what SA stands for? Surface area. Surface area equals, and then we're used to in this class doing a vertical line through the equal sign. That just keeps our left and our right sides organized. Okay, now I could write 6 different equations, or sorry, 6 different formulas to find the area of every single rectangle. But in the last video, I was talking about how actually some of these rectangles are identical. Like how about the front and the back? Aren't those the same? So if I found the area of the front, A sub F, that F doesn't have any mathematical meaning, just means area of the front. If I found the area of the front, would I have to also add the area of the back? I could add the area of the back. Or what if I multiply the area of the front by 2? Whatever the area is here, if I multiply it by 2, that means I'll have found the area of the front and of the back. And then I'll already have 2 of the rectangles out of the 6 done. Well, what other 2 are identical? How about this blue left side? So how about the area of the, and we'll put L for left side. That's here. If I find the area of this left side, which rectangle is identical? Well, this side, the right side. You can't see it, but it's over here. So if I multiply that left side by 2, I've now found the area of both the left side and the right side. Well, how many rectangles do I have left? I just have the top and the bottom. So if I find the area of the top plus the area of the top, I could add another area of the bottom, or I could just multiply whatever the area of the top is by 2, and now I have the area of the top and the bottom. Okay, this is kind of complicated looking. Well, the surface area, that's just going to be SA the whole time. So I'm just going to leave that as SA. I'm not going to change that. And if I don't change it, if one of the sides of the equation doesn't change, I can leave it blank. I could write SA here, or I could leave it blank, just so, you know, I don't want to write as much. Now let's see what's happening here. Area of the front. Well, the front is this green rectangle. How do we find the area of a rectangle? Well, I don't know if you remember, but the area of a rectangle, or a parallelogram for that matter, because this is a parallelogram. Remember, 2 pairs, there's 1 pair of parallel sides, 2 pairs of parallel sides, is equal to base times height. And these have to be perpendicular. So this 7 and this 3, that's the base and the height. So to find the area of this rectangle, it would be equal to, the area of the rectangle would be equal to 7 times 3, right? Well, hey, the area of the front is the area of this rectangle. So I could just do 2, and this is multiplication, so I'm going to use a parentheses. And then the area of the front, we just figured it out. 7 times 3. 7 times 3, that's 21. plus 2. Area of the left. Okay, the left side. The left side is this blue rectangle over here, right? Well, isn't it the same thing? Isn't the area of the blue side, wouldn't it also be the area of a rectangle? Isn't it base times height? So that's 4. That's how long that is. It's 4, and I'm not drawing it very well, but I think you get the point. That's 4. How tall is this though? What's the height? 4 by, oh, do you see this 3 over here? All of the edges that are going up and down must all be 3. So this is 3 inches. So this is 4 and 3. So the base and the height are 4 times 3. And so what is that? Well, I didn't do this last one. I should have finished it, right? 21. Technically it's inches squared, isn't it? Ayabuka. Well, I'll put them there, even though it's just to remind us that area square. Yeah. Okay, this one then is 12 inches squared. So now we have 2 times the area of the left. That's 2 times 12 inches squared, plus 2 times area of the top. Area of the top. Well, the area of the top, let's look at that top. What shape, what polygon is that top? What is this? Wait, that's a rectangle too. So it's just like this one over here. So area is equal to base times height because it's a rectangle. How long, I'll use a different color. How long is this dimension of this top rectangle? Well, that's 7, right? Because all of these sides are 7 going from left to right. And then how long is this one? Oh, that's 4, right? So the parallel edges are the same length, right? So the 7 is parallel to this, so that they're both 7. The 4 is parallel to this, so they're both 4. And the 3 is parallel to this, so they're both 3. So this is 7 by 4. So 7, and I realized I'm blue still, so I'll go back to red. 7 times 4, and we get 28 inches squared. All right, so that's 2 times area of the top is 28 inches squared. Why are we multiplying these by 2 again? Oh yeah, because they all have a partner that's identical. So the area of the front is the same as the area in the back. So we have to multiply 21 times 2. Can you do it in your head? That's 2 groups of 20 and 2 groups of 1, 42. Plus 2 times 12, that's 2 groups of 10 and 2 groups of 2, that's 24. Plus, 2 groups of 28. You know how I'm going to do that? I'm going to do 2 groups of 25, which is 50, and then 2 groups of 3, because it's 3 away from 25, right? 8 is 3 away from 5. So 2 groups of 25 is 50. 2 groups of 3 is 6. That's 56. And if you did it in a different way or used a calculator, totally cool with me. I'm not using a calculator, which is cray-cray, but I think I can do it. I'm adding all these together. 6 ones plus 4 ones, that's 10 ones, plus 2 ones, that's 12 ones. That means I have more than 10. So I'm going to have to borrow 1 in the tens place. 1 10 plus 4 tens is 5, plus 2 tens is 7, plus 5 tens is 12. And what are these units? Oh yeah, we're finding out how many square inches, my pen stopped working, square inches it takes to cover this whole thing. So that's inches squared. So the surface area, and notice I have my equal signs all the way down, surface area is equal to 122 inches squared. That's how many inches squared, little square inches. There, I'm drawing them. Oh, geez, that's really bad. Oh, Mr. Plunkett, go home. It's how many square inches would cover the outside of this thing, all right? Okay, the surface area of a solid is the total number of blanks it takes to completely cover all the faces. Squares. Area is square area. Oh yeah, every face that has a parallel and congruent face is also a, oh yeah, if they're faces that have a parallel and congruent means identical. So the front has an identical rectangle in the back that means they become bases. Which is why we call it. Oh, it's also a base, not bases. So every face on a rectangular prism is also a base because they all have a parallel and identical or congruent rectangular face. To find, and that's why we call it a rectangular prism, right? The base, whatever the base is, that's the word that goes here. To find the surface area, you can multiply the area of each face, which is also a base, by, well, what number did we multiply by every time? 2, because there are 2 of each rectangle. Awesome, everybody. You did your first surface area problem. And so I'm going to stop this video and go on to a third video. I'll be right back.